Welcome to all to part 9. Remember, now part 9 and part 10. I am taking 2 more classes for W and post section only for practice purpose. Title I will give practice questions. And I am not going to explain much. Already so many classes, everything repeatedly explained. So I will tell once again, class is meant only for those who are regular and dedicated. If someone will come to the class suddenly and he may tell, this person is not telling anything, let them tell, no problem. Okay, start. What I will do is application to beam problem. This I told long back for single line post. So go and see there, I have written there, application to beam problem. Start. Question dictated. I will read the question. A simply supported beam is loaded by a dead load of 16 kN per meter excluding self weight. Either they can tell excluding self weight or they can tell in addition to self weight, whatever want they can tell. So I am telling excluding self weight and a live load of 20 kN per meter. Now, cross section of the beam is 200 mm by 500 mm. Tension reinforcement consists of 2 bars of 25 mm diameter at effective cover of 50 mm. And compression reinforcement consists of 2 bars of 16 mm diameter at effective cover of 45 mm. Taking M25 concrete and remember FE 550 grade star steel. I am telling you, FE 550 grade tar steel. Find maximum allowed span for the beam. That is the question. Okay. Now, start solution. What they want? They want the span. So start from there. Let L be the maximum allowed span for the given beam in meters. So span is L, meter. Now, I already told you require factored loading. So let W be the factored UDL. You can write here. W is what? It is factored UDL. Factored UDL in kilonewton per meter. Later you will see. First, dead load excluding self weight 16. So self weight you have to calculate. Enjoy the self weight. 0.2 into 0.5 into 25, 2.5. So dead load including self weight is 16 plus 2.5, 18.5. Live load given is 20. So dead load plus live load is 18.5 plus 20 is 38.5 kN per meter. Remember, they told beam is loaded by. That means it is working load or service load. Understood. But we want factored load. So taking gamma F is 1.5. Factored UDL is 38.5 into 1.5, 57.75 kilonewton per meter. Now, calculate factored maximum bending moment. Simply support beam with UDL throughout the span. Due to symmetry, it will be at center WL square by 8. Substitute W into W means WUL square by 8 kilonewton meter sagging BM. So bottom tension, top compression. That's why this is extreme compression edge. This is all known for you. Okay, now class. I already told, if an unknown is asked what to do, find the maximum factored maximum bending moment in terms of the unknown, find ultimate MR of the cross section and equate. I told already. See, if you are not gone through earlier classes, part by part, once in a while if you study, my class is of no use. If you want thorough knowledge, every class, everything you have to follow. Now we have to find ultimate MR for given cross section. See, over. I wrote here B200. See, D, AST, ASC. Rounded means you have to calculate it. See, D you have to calculate. AST you have to calculate. ASC you have to calculate. D dash 45 given. M25 concrete, no problem. See, FE 415 steel. Class. We see right here. Class means I am telling something here. In all the problems so far, we used to write for Fy equal to so and so from IS code XU max by D. But this time, FE 550 for that in IS code, x max by d is not given. Therefore, I told earlier, get from basic equation. So write that way. Y, see, IS code cannot be used for x max by d. Y means, I am telling now, already told earlier. Okay, so we have x max by d. This formula told for you and already explained earlier. Today's class is fully practice question. Get x max by d. Now continued to find ultimate MR. Okay, 1 minute now. Ultimate MR, I will explain somewhere here. I will remove this one and write only numerical part. Anyway, continued. Continued, something I am telling now. If you cannot solve now systematically by using these numbers, then I will tell not eligible for learning. It is explained so much earlier. So therefore, what way I solved earlier, that is previous question, work out. I am not telling anything now. This is the initial XU. Somebody will ask, how you got it? I will tell you, okay, you don't get it, leave the class. I will tell that way. If they are in front of me, I will tell, leave the class, leave, don't come to me. 199.58, note, limit, 0.001913, you know, get this value. How means, don't ask me. Trial 1, epsilon SC, FSC, 160.01. So, initially 199, no, changes. Start, second trial, 0.0252, 442, 162.15, slight change. Again try. Now what happens is, when it is 160.01, strain came 0.00252. When it is 162.15, strain came 0.00253. See, this is 0.00252 and 253, very difficult in the IS code. See, SP16 you cannot use. Why? Because FE550 steel. So, it is almost equal to same 0.925 FY. So, 440.49. So, stop here. Same XU will come. Stop. Over. Stop. Confirmation. XU, FSC. Calculate ultimate MR. Now, last step. You see, first time in my class, such a short class. It never happens. Such a short class, very rare. Very rarely, such a short class will come. Okay, now, last statement. Okay, I'll complete. Therefore, after this everything is over, come here. Equating, right here, factored maximum bending moment to ultimate MR of cross section 57.75 into L square by 8 equal to 183.51. Therefore, you will get maximum allowed span for the beam L equal to you get in meter. Okay, now where is the calculator? This I have not calculated. I will do it here only, not much. 183.51 into 8 divided by 57.75. Calculator is not on. 183.51 into 8 divided by 57.75. That is the answer. 5.04 meter. 5.04 meter. Okay. Over. All the best. All the best. For all those who get the answer, who solve correctly. That's all I can tell. Sometime offline class, I used to make a fun. See, by equating factored maximum bending moment to ultimate MR, you are getting unknown load. But what you will get? You get the factored load. So permissible load equal to divided by load factor is there. So in the class I will write, this is the maximum value corresponding to factored load. Therefore, maximum permissible equal to 5.04 divided by 1.5. I will write in the board, ask the students. They will tell the answer. Sir, 5.04 divided by 1.5. Sir, 3.36 meter. Then I will tell them. factor of safety is for the load or material, not for span. Tomorrow, member can be overloaded, no doubt. Material property may change, it may become weak. Today's 5-meter span, tomorrow will not become 7.5-meter span. Then they will tell, oh, span, there is no factor of safety, there is no permissible span or factored span, only one span. Loading, already we consider factor. Okay, all the best. I will take one more class later, part 10. One more application I will take. There also, ultimate MR this way. But there, I will set the question so that instead of 1, 2, 3 cycle, it will be over in only 2 cycles. Last class, 4, 5 cycles. See, now today 3 cycles. I will see that it is over by 2 cycles. Now, I can set the question the way I want. You don't bother. Some will ask, sir, how you set it? You solve the question given by me. How I set means, you don't try to come to my place. Let me be here teaching, you learning only. Okay, thank you.